Welcome to this edition of Hubbard-Hall's Seen Solved podcast. I'm Tim Pennington, editor of finishingandcoating.com, and today we're talking with Connor Callais, technical application specialist at Hubbard-Hall. Our topic today will be paint stripping.
This is Seen and Solved with host Tim Pennington, brought to you by Hubbard-Hall. Better results, less chemistry.
I've seen Connor give some presentations in the past. He's very good at it, and he's going to be telling us all of that we need to know about the paint stripping process, which process you want to pick, and any other advice that he has. Connor, thanks for joining us today.
Thanks for having me, Tim. How are you?
Doing splendid. Tell us a little bit about yourself. I know, like I said, I think last time I heard you speak was in South Carolina. You gave one of the better presentations. I loved it. But tell us a little bit about yourself, your background, all that you do at Hubbard-Hall, and even your path to the company.
Sure. So I've been with Hubbard-Hall and also been working in this industry for coming on 3 years now. I was in undergraduate school at a small school in South Carolina, and I studied chemistry and math there. And originally I was going to go to med school, decided that I didn't want to deal with all that and all the debt for several years. So I decided to pursue a PhD program. I started working with a nanocomposite polymer lab at the University of South Carolina, and did that for about a year and realized that I really didn't want to continue that path. So I was looking for an easy out or easy escape so that I could get to work and not have to be in school anymore. So I kind of just stumbled on an opening at Hubbard-Hall and met with the team here and went through the interview process and was lucky enough to get a job with them back in probably summer of 2019. And from there, I've been working with our technical department, which kind of bridges both the development and the application side of our product lines. And I work with the sales and our customers and prospects to integrate these products and find solutions that benefit their applications.
Right. You know, you could always go back to med school if you wanted to. You could do that.
I could.
You don't have to pay for it anymore. You don't have to worry about those loans. They're going to take care of those. But anyway, but no, what college was it in South Carolina? I'm curious.
Small school called Wofford College.
Wow, that's not a small school. I hear about it.
Yeah.
I know a friend that plays basketball there. There you go.
Oh, very nice.
All right. Yeah, there you go. But so like I said, you've been with Hubbard-Hall for how many years now?
3.
3 years. Okay.
Yep.
Just curious, what percentage of the time, I guess you got hired right before the pandemic, so that kind of put a dent into the travel. But how much are you on the road now and in shops and seeing things?
So we had a little slowdown once COVID kind of took us all in, but probably after about 6 months or so, we started getting back on the road, working with customers. Definitely been utilizing online platforms a lot, as is everybody. But I'd say things have been picking up pretty rapidly as of late, and probably 40 to 50% of my time I'm out in the field working with customers or trying to help troubleshoot or solve problems and the like.
Right. You know, it's funny, you can learn these things in college, like I said, chemistry and all these other things, but I guess to get into a facility, see how the things are running, and then actually using that application, right? I mean, seeing it in real life, how things are done, how they're made, how they're manufactured, that had to be, I guess, pretty interesting to merge what you learned in the classroom into what's happening in the real manufacturing sector.
Absolutely. It's like one big long episode of how it's made. You really get to see all sorts of different applications, and how it's very interesting how many steps and touch points just the simplest little thing goes through before it hits the market.
Right. Right. And one deviation can cause all the problems in the world, right? I mean, that's
absolutely
what I'm saying with that. So finishing a coating industry, we're all talking about putting coatings on, getting it finished, but you are specializing in getting coatings off, right? I mean,
yes,
there is a need for that. Tell us why facilities, shops, why do they need to get rid of paint? Why do they need to strip parts?
Sure. So one of I'd say the primary cases we see that people have to remove paint or other similar organic coatings would be for the racks. I mean, as racks and different masking materials are run through a paint line with parts, they slowly accumulate a really large buildup of paint that has to be removed from some sort of mechanism, or it's just going to be rendered useless. Reclaiming those is both very cost effective because they need to not have to just buy new racks or maskings over and over again, but it's also an efficiency saver in the actual process, because if you don't have racks, you can't paint parts. If you can't mask the materials, you can't paint the parts. So having those readily available in a clean and effective manner is really important to maintaining the efficiency of all these different painting applications.
Right, because we're talking grounding, right? I mean, you've got to have the proper ground. The current has to be going through the racks, correct, to get to the parts. And I see that a lot where the biggest problems or errors is that shops are not properly cleaning and stripping their components, correct? Is that what it is?
Yeah, absolutely. And then I'll tell you another aspect of paint stripping that really is a value add for many people is just part reclamation. If you have a paint defect on a part that won't meet quality standards, well, rather than scrapping that entire piece, you often can remove that painted coating that was applied, and then sometimes there may be a couple steps in between that have to go before that part can be repainted, but you're saving on all those steps that have gone into that part prior to and not having to reinvent that also.
Right, right. You know, I once saw a picture, I think it was someone showing a part that needed stripping, and it must have had 72 layers of paint on it. I mean, it's such an obvious thing sometimes, but I guess a lot of facilities, why they don't pay a lot of attention to it, it isn't really a value-added service to it. It's maintenance, right? It
right.
really is going in and making sure that you've got the paint stripped off so that you got proper ground. And I guess a lot of them don't understand that, you know, even a minuscule amount of paint or coating on a part or a rack will diminish the amount of current, which will then result in a flaw, correct?
Absolutely.
Some type of flaw in the coating.
And even outside of e-coating, even if you're just doing a spray powdered paint, after you build up so much paint on those racks, they begin to not really hold on to the part as well. I mean, you have this, if you have a very thin metal fixture that you're hanging your part onto or putting it on a rack, if you build up a certain amount of paint, it's not going to have the same ability to hold on to that paint in the process, especially if it's being sprayed with a powder coat or something similar.
Right. Well, aside from stripping, what else do they do? What else can they do? I guess they could just throw away the racks and get new racks, which is so expensive to do. And even the masking parts, right? I mean, that's the alternative to actually stripping the thing. Or is there more?
Right. So oftentimes people they'll run a rack or a masking as many times as they can effectively get out of it before it starts to kind of diminish the quality of the coating on the part that you're working with. And once you kind of reach that point, there's two main methods that are kind of used today. You can use either a burn-off oven, which heats them up to the parts and everything, all the coatings on it, heats it up to several hundred degrees and essentially just burns off any of the organic coating that was on the rack. Another option that's sometimes used is using like a fluidized sand bed, where you have a molten salt bath or sand bath that racks are dipped down into, and it similarly just annihilates the coating off of it.
Right. So, you know, fuel costs are so expensive. The heaters for the ovens, that almost rules itself out. Plus, you've got a lot of air quality issues. You have to have scrubbers and things like that in that. So I guess, you know, I'll ask this question. I think I've answered a little bit, but why is paint stripping the best route to take with that? I guess it is the most effective.
Sure. So you touch on a great point. The energy costs of running any of those burn-off ovens or sand baths, they do 9 times out of 10 have to use a natural gas or some sort of combustible source for the heat. With paint stripping, you can use gas heaters, but you also have the option to run electric heaters or use steam generated heat, which gives you dramatic energy savings, because the temperatures at which paint stripping occurs are never over 200 degrees. So you really just have the solution that you're warming up somewhere between 140 to 200 degrees, depending on what you're stripping and what sort of application you're trying to run. And you have multiple cost-effective methods that you can use to heat that source.
Gotcha. So talk a little bit about the difference between organic and acidic applications. And which do you think is a better one?
Sure. So traditionally, paint stripping, which kind of gives to some of its negative connotation, used to be done with methylene chloride, or DCM, which is a very common solvent that was used with somewhat relative frequency in the 80s and 90s, but then kind of started to learn more about the negative health impacts of using that chemistry. So it really kind of ran out of fashion as a method to strip. So organic paint strippers today are much more safer and user-friendly. They have really high boiling points, so they aren't evaporating into the air while you're using them. Just a very miscible amount gets actually released into the environment. That's kind of where paint stripping started to regenerate its use and effectiveness in the industry. We use a variety of different solvents combined together to remove the paint. Organic strippers are often used in applications where you have multiple metal substrates that you're having to strip, because the solvents they're effectively inert with all sorts of different metal substrates, but also they work by delaminating the paint off of the surface. So we'll talk a little bit more about other mechanisms later, but delamination is essentially where the paint goes through swelling and the solvents are able to get between the paint and the substrate and lift it from its surface. And you typically see these parts strip, or racks strip, in a sense where the paint kind of peels off as sheets. Or if you have multiple layers, the paint kind of peels off layer by layer, and it sort of swells, and then you can filter out those solids from your stripping solution. Right. When we talk about acidics, we really kind of classify it with organic strippers and aqueous strippers. So the aqueous strippers would kind of encompass both of our acidic ones and our caustic-based strippers as well. Acidic strippers are really effective with cleaning materials such as aluminum, where you couldn't use something with a high pH on aluminum, or otherwise right, it would destroy the part. With acidic strippers, we're able to remove a variety of coatings and off of most non-ferrous metals, including CARC coatings, which are chemical resistant coatings that are often right, used in military applications and sometimes in marine applications. Those coatings are very difficult to remove from parts. Right, because they are chemically resistant.
They are chemical resistant. There you go. That's in the name. There you go. So.
Exactly. Right. So we use, in our acidic strippers, we use an alkyl sulfonic acid base. So it's not a mineral acid, not a super strong aggressive acid. So it's not going to necessarily attack the metal, but it does work in softening up that paint, getting it to swell, and helping aid the delamination off of the material that you're using. Right. We use acidic strippers quite frequently in applications that have those CARC coatings that they have to remove from different military equipment whenever they go to refurbish or remanufacture those. And we see that as a very effective method for removing those type of coatings.
So, and I'm seeing more shops that are actually the masking. They're trying. Masking is expensive, and it's lately it's been hard to get. I mean, yep, and so reusing that is just a money saver for them. So, I mean, are you seeing more and more of them, try to, strip their masks and get as much out of them? Some of them I've heard them say they can get up to 6 to 7 times more use out of those
Absolutely.
masks.
Yeah. So we, case that we've kind of seen and solved over the past few years is we work with a metal finishing shop that they have several different types of maskings that they use with great frequency. I mean, these maskings on a single part will sometimes run 2 or 3 times a day, 4 to 5 days a week. And being able to continue to reuse those maskings and not have to deal with reordering new ones or degrading the material that the maskings are made of is really important for them to be able to maintain that level of production and also kind of minimize their operational costs. So we use an acidic product, Aquastrip ACB, and they run it at probably around 140 to 150 degrees. And they can just put their maskings in a barrel and tumble them in that solution for 15, 20 minutes. And the masking materials come out good as new. One question people often have when they're looking at stripping maskings is this chemistry going to affect the integrity of that masking itself? Especially when you have supercritical components that you can't have little bits of silicone kind of coming off and placing onto the part. And being silicone at these relatively lower temperatures, they're able to withstand that several times over. We can often see people able to get 10 stripping uses out of a single masking.
Right. And like you said, I know I'm talking to a lot of shops, to get masking, it takes a long time. I mean, not much of it, I hate to say it, not much of it is made here in the continental US, it's overseas. And so it's just a supply chain issue. So
they're all built to spec too. It's not, you can just get an off the shelf masking. It has to be made specifically for the part that you're going to process. That just adds a whole nother step in that lead time as well.
Okay. So you talk about organic, you talk about acidic. Give us a little insight into the caustic solutions that are out there for that.
Sure. So caustic paint strippers are really kind of taking off, especially with the rack stripping of steel racks and even steel components as well. Compared to organic strippers, particularly, the cost of the chemistry is significantly less. So you have a much lower regular operational cost with using those processes. But they're very much, I would kind of classify them as a workhorse product. You can have steel components that have many, many layers of paint that are on them, and you can heat those solutions well up to 190 or 200 degrees, and they really can work to really destroy any of that coating in a pretty timely manner. When we say a caustic stripper, where you have a base builder of sodium hydroxide or potassium hydroxide, and then you also have the organic additives that are kind of added in. So it kind of works as more of a biphasic solution. So you have that aqueous component with a smaller organic component, and those kind of work together in unison to really not delaminate the paint that you're trying to remove, but really dissolve it. It breaks the bonds between the individual paint molecules, typically a polyester or an epoxy-based paint type. Those are going to be 9 times out of 10, we're going to use a caustic product for that process. We touched on it a little bit before, but you really want to make sure you have that impingement and overall agitation of the bath itself, because it will split out into your aqueous and your organic layer. So being able to make sure that solution is well mixed really is going to render you some effective results.
Right. So you mentioned with the delamination, I mean, and I've, in simplistic terms, I've, stripped furniture and doors, and the more it's on there, the harder it is to get off. So what do you recommend? I mean, is there a cycle time of how many coatings is on a rack or anything like that they should be really pulling it and and getting it stripped off? Or because I guess the more coatings, the harder it is to get it right down to the bare metal then.
Yeah, absolutely. So the actual strip time it will take for, say, one application or one layer of paint to be removed does have some variability. It kind of depends on the porosity or the structure of the surface structure of the substrate that you're stripping off of, and then also what sort of coating and that particular coating respective thickness, how thick that coating is on the part. But generally, we're able to strip coatings in about, I want to say, maybe 10 to 20 minutes per layer is our average or standard. Sometimes we can get them stripped quicker. Sometimes it takes a little bit longer. And then we really sort of see that that strip rate tends to be relatively linear with the number of coatings that you applied. So if you have a part that takes, let's say, 15 minutes for a single layer to strip, well, if you have 20 layers on there, you're looking at 300 minutes or close to 5 hours to strip. And it really kind of continues on that linear rate for stripping.
Right. Right. And we were talking, I mean, again, stripping is a maintenance issue. But it's a money saving issue. And they don't think a lot of shops actually realize doing it properly can really put money back in their pockets with that. But so, I've seen a lot of facilities where they have a very good paint stripping operation. They've got it set up, they pay attention, and then some who don't. So, what advice would you give, or what have you seen about how to set up a really good and maintain a really good paint stripping operation?
So I'll kind of answer it in this regard. When we see issues with paint stripping, it 9 times out of 10 is not the product that's the problem. We either have an issue with dwell time, which is a simple fix, just leave it in there a little bit longer, or we have an issue with agitation. Agitation is just as important as the product that you're putting in there and the temperature that you're running at. If you don't have that agitation in the stripping solution, you're not able to remove those coatings. You'll be able to swell them and degrade them to an extent, but if you don't have the impingement of solution kind of rushing in and hitting that part, you're not going to be able to remove those coatings effectively. We typically will run agitation with a system called an adduction system, whereby you're removing solution from the tank, it's being pumped through a high pressure filter, and then it is sprayed out of nozzles back into that solution underwater, or under the liquid layer. So it's not spraying outside of the tank, but it's spraying that solution directly into the part that you're stripping. And that usually occurs at about 40 to 50 PSI. And that impingement action is what really does the lifting work of removing those coatings from the part. So kind of circling back, I said we had the two main mechanisms that a paint's going to be stripped. It's going to be delamination or dissolution. Dissolution kind of occurs more with caustic paint strippers, but once you kind of break down that bond either between the paint molecules themselves or the adherence of a paint layer to the substrate, that's kind of your first stage, either the delamination or the dissolution. And then it comes to the physical removal, and that's where those adductors come in.
Gotcha. Yeah, I guess with any operation, especially with any chemistry, any other type of operation, there are some safety protocols to follow. I mean, what are some that and even there's regulations, right? What are some regulations that shops really need to follow to make sure that it's safe for their employees, and also for the parts as well? Sure.
So when it comes to using the paint strippers, I mean, as with any wet application you're going to be using in the field or in the industry, you're going to want to make sure you're using your proper PPE. I mean, this is a heated solution of chemistry, so you're going to make sure that you're wearing your eye protection and any respective gloves or aprons that your operators may need to use. And you also want to make sure that everyone's thoroughly trained on what exactly they're dealing with. If you're dealing with an acidic solution, you are heating up acid, and you want to make sure that you're minimizing any potential for contact between the operator and that solution. And then similarly, you're going to want to make sure that wherever you're performing this application, that you're able to adhere to the appropriate discharge regulations. So we're really not having to dump this material often. If it's a well-maintained bath, the solution itself should theoretically never have to be completely disposed of. So you're never having to dump a full bath to wastewater treatment, but you are going to have some of that residual solution that is brought up from the part or the rack into your rinse area. And you want to make sure that you appropriately treat that rinse water.
Right. So, wrapping this up is a couple takeaways. You've talked a lot about what you've seen and some of the solutions to solve part of it. Let's just recap real quick. I mean, things that finishers and coaters should always keep in mind with these operations. So one is that, kind of borrowing a phrase from Nike, just do it. They need to be able to do this and have it consistently done, correct? They need to have it done on a routine maintenance basis.
Right. And you really see the most success when they don't treat this sort of application as an afterthought or something they just have to do occasionally. If it's an application where they take the time and the resources to maintain this bath, maintain the operation and the use and the bath life, they really can get a considerable return on that investment itself.
Right. We talked about there's the organic, there's the acidic, and the pros and cons of both of that. But really, I think some of the bigger takeaways, what you were mentioning, was having a really good set stripping operation, have protocols, have procedures, make sure everybody knows about it. But that's got to be kind of, I think, one of the best takeaways is they need to have that in place and really know that there's a lot of solutions out there for them to recoup some of their costs, right? So they're not having to trash racks. Or parts are expensive as well, and also with the masking part of it. So Connor, is a takeaway from what we've all talked about. Just give listeners just a few bullet points that they need to do, which is, again, they need to have they need to think about the paint stripping process. Correct? They need to have it in place and have schedules and procedures and policies of how they're going to be doing this.
Yep. And one thing we talk about as well is just the general bath maintenance. I know we've kind of said that term in the past, but what it really comes down to is, are you removing those paint solids from the system? Those paint solids are what's going to really blind up the product from performing effectively. Those are typically removed either through like a bag filtration, where you have predetermined micron size for the type of paint that you're stripping, and it removes those from the solution and returns the product back to the tank that is solid free and able to continue to perform. But you can also filter with centrifuge filtration as well. Both of those methods are effective in removing the solids from the bath. And then this is more common with our aqueous or the acidic and caustic components. But when you're operating those products at 150 to 200 degrees, the main loss you're going to see is just water from evaporation. So when we start up a application, we try to kind of get a feel for what is our rate of evaporation, whether it be a few gallons an hour, depending on the size of the tank. And then we want to make sure that we're routinely adding back fresh water to replace that's lost from evaporation. So that will maintain the concentration and the relative performance of the bath as well.
Right. Yeah. Do those simple things, and there should be no hiccups, I guess. Like I said, you don't have to keep dumping it or anything like that. Just maintain it, and it will it'll give you good service, right?
Absolutely.
Yes, great. Good advice. Appreciate you talking to us about that. And like I said, I want to thank, this is Connor Callais, Technical Application Specialist at Hubbard-Hall. And you'll want to join us again next time on this podcast and this show, Hubbard-Hall's Seen and Solved.
Seen and Solved is brought to you by Hubbard-Hall. Better results, less chemistry. For more podcasts, go to hubbardhall.com or wherever you get your podcasts.